I will start recording. So I'd like you to close any models that you have open. Okay? And having closed them, I would like you now to open up a model, create a new model that will be called Hybrid Clinic. Okay? Hybrid Clinic. And I'm going to say SIRS. This is actually going to be an infectious disease model, but we'll talk about how the principles apply to communication of health behavior. And I would like the model time units to be hours. Okay, are we okay with that? Okay, now with your leave, I'm just going to go and place this in the requisite spot. And then example, models built in class. Here we go. Okay. So hybrid clinic, SRS, hours, finish. Okay.
Can I just
Yes.
ask a question in terms of, you set hours there. When you're doing a hybrid model like this, I mean, one part, like the desk part, might actually, minutes or hours might be more relevant.
Right.
And then you might be stepping back at that in terms of, where weeks or months.
Yeah, think about chronic diseases even over decades.
Yeah, so when you're setting it at that stage, you choose the smallest unit, or what do you do?
Okay, so this is a very good question. And it's a question where the answer has several components. So first of all, it's important to understand what we're setting there when we said hours as the time unit of the model, or indeed when we go up here, we say model time unit and we choose hours. First, I'd like to delineate what that's not doing. That's not say, so if you choose, let's say, seconds rather than hours, it's not going to make the model run any slower, okay? It's not like you've got to do more work, you're suddenly jumping in seconds versus in hours versus in days. It's nothing like that at all. This is just the yardstick we use to measure time. What does 1 mean? What does 2 mean? Does it mean 2 hours, 2 minutes, 2 seconds, 2 weeks? It's a choice of convenience, therefore. But it's a choice of convenience that you have to consider your multiple pieces of the model. And I think it was to that, Matthew, that you alluded, that if you have these models that are sort of multi-scale in a temporal sense, that you have some pieces that are very fast acting and some pieces which are slow, what to choose for that. And the answer to that is, you're right, that is texture associated with it. Fortunately, in AnyLogic, we do have the luxury of being able to specify the time units that we wish to have associated with many things. And it will take care of the appropriate unit conversions. So we can choose within our model to have some parameters be specified on a per day basis, others on a per month basis, others on an annual basis. As long as we are consistent with them and tell AnyLogic, yes, this is per day or per year, it'll be fine. And as a result, it's very rarely these days a straitjacket where now you have to convert everything to minutes or something like that, just because some part of your model, the finest grained component, is in minutes. Far from it. You actually will be able to you'll be able to set many different areas of the model, use different time units, but you have to be careful about it. You have to be explicit about it, and you want to use names that indicate those things. So this is an annualized immigration rate, or annualized hazard, versus a weekly incidence rate or something along those lines. And as long as you're clear about that and you tell AnyLogic to be so that it's clear about it, things should be okay. Okay? And there's many components of that will be familiar. as a general rule, what I would advise is when you're building a model for real use, you err on the side of transparency. So err on the side of familiar units, and you maintain metadata in the form of indicating the original number that you drew from some source using that. So if the source you have specified this in as a per month rate, or specified this as a per day hazard, you want to use that number, give the source as the reference, and indicate the appropriate unit, and then where it's used in the model indicate it's that unit. So you try to preserve the appropriate metadata about the unit that was in the source you used for it. Are those comments helpful?
Yeah, very helpful.
Okay. So this is our yardstick of time, that hours thing, and in that sense, it's not going to paralyze our model through slowness to use a different one. Okay. So, ladies and gentlemen, right, we're going to hit mobility here as well. This is going to be a sort of an omnibus model. Okay, so I'd like you to add personhood to this model. Personness. What do I do? Anyone tell me? Right-click on this, new agent type, and I'm going to say person, capital P. Instead of all possible people associated with it. Oops, person, boom, okay. Very good. So, person, let's go to palette. Let's add to them a person-like representation. Just like that, okay? And I'd like to add a person population now. Where does that population live? It's after lunch.
Maine.
It lives in Maine, indeed. So we can drag person over and call it population. Now, by itself, does dragging over and call it a population make it a population? What else do we have to do? We have to declare it a population of agents. Now, right now, it's going to say 100 agents. But look, we're increasingly mature in our understanding of any logic. Suppose we wanted to be able to change the assumption of population size from experiment to experiment. What could we do? What could we add that would allow this model to use different experiments for different population sizes for different experiments? What could we do?
A parameter?
Yeah, we add a parameter. So let's add a parameter in from the palette. You folks are really building on your knowledge. Okay, we're going to add a parameter in, and it's going to be called population size. Okay? Population size. Good. What sort of parameter is it? Is it a double? Is it a Boolean? Is it a string? It's an integer indeed. And its default value will be 1200. If we don't specify it elsewhere, we'll make it 1200. Now, just because I called this population size, is that, if I ran this with 100 versus 1200, would it make a difference right now?
No.
No. What do I need to do to make it operational? To sort of make this actually make a difference? I need to do what?
Set that initial number of agents.
Yeah. In the population, the initial number of agents needs to be given by what?
Population size.
Population size. Population size. Now, ladies and gentlemen, I want to draw your attention to the fact that in many places, like this initial number of agents, any logic had a number filled in there originally. Do not get set in this mindset. Just because you see a number, you think it has to only be a number. And generally, you can put formulas for things. You can put calls to a function. You can do all sorts of things. So try to break out of this mindset. Just because there's a number, it wants a number only. It needs something that turns into a number, and this denotes an integer, which it can use, turn into it. But we can put lots of things here. We could call a function that determines the population size. Reads it in from a database, figures out how many people are in the database, creates a population of that size, and then populates each of those people in the model. Boom, 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 boom. Is that okay? Okay. So, ladies and gentlemen, now suppose we want this population right now to appear to appear at random places within this model. I'm going to show you an alternative way to do that. Where have we done that thus far? If we wanted this population to appear scattered all over at random, where have we done that? Anyone remember? It was in the population. Where did we go? We did this initial location. Remember that? You remember that? We're going to do this a different way now. And this is going to hark not back, but forward to some things we'll be doing soon enough. Instead of doing it there, we're going to go to main. And in main, we're going to go down main. And down main here, I'd like to set it for the layout type. Instead of user defined, I'd like to use random. Okay, and where did I do that? I went to main, I selected main, and I scrolled down to the space, ladies and gentlemen, and network area. And there, under layout type, I chose random. Are we okay? Okay, Dylan? Or Annie? Question?
Oh, I see. There was a head in the way. I couldn't see it.
Yeah.
Okay. Okay. So, ladies and gentlemen, who else needs help? Annie stands ready. Okay. Okay. For those who are ready, you should be able to run it and see something like that. Do you see something like that?
Okay, so that's what it was.
Okay. So who would like me to show something I've done? Who would like me to show you anything?
It was, so the network type is random, yes?
Yes.
The layout type is random?
The layout type is random, not network type, but layout type. Layout type. Okay? Are people okay with that? Okay. So, ladies and gentlemen, that's just to verify things are going. Now we're gonna take a right angle turn. We are going to go add to this model new agent type, and this is going to be an agent type home, the capital H. It depicts homehood, homeness. Okay? And within home, we're going to lend it a representation visually. From our palette, we will go down here to the pictures area, and ladies and gentlemen, we will pick a house, and we'll put it up there. Boom. People okay with that? Okay. Okay. So, ladies and gentlemen, now I'd like to add a population of houses. Okay? And we're going to place them into main. So how would we add a population of houses, of homes? Anyone? How do we add a population? Drag it in there indeed, and we'll call them homes. Homes. Okay? This would be a population of agents, and we're going to make its population size, ladies and gentlemen, be population size divided by 3. So the number of agents, there'll be on average 3 people per home. Okay? Now, this is actually a case where it's an integer division. So it's going to figure out how many times 3 goes into the population size as an integer. So we're not doing a 3.0. We're doing it 3. And in general, if you're dividing one integer by another in any logic, in Java in general, it's going to be performing that in an integer way. Make a note of that, because that means if you put in your model 2 divided by 3, then it will turn into the value 0, because it goes in 0 times. Just be aware. By contrast, if it's 2.0 divided by 3.0, it will be 0.66666. Okay. Ladies and gentlemen.
Sorry, so that truncates, not rounds.
Correct. It truncates, yeah. Yeah. Thank you. Okay, ladies and gentlemen, I would like you to now run this model. And what do we see? What lies before us?
People and houses.
Okay, there's people and houses. Good. Great. Okay, ladies and gentlemen. I would like you next to go, and I would like to, for person, now we're going to be doing something which is going to push your comfort zone potentially. Okay? So I'd like you to go to person, and I'd like to add into person a parameter. And the parameter is going to be called home. Okay? So it's going to be called their home. Okay? So from the palette, we'll go to the agent palette, drag in a parameter, and this will be called home. Now, what type do you think home is? What describes the set of possible values home can take on which home can take, that can be taken on by home?
Home agent?
It's the home, yes, the home, what we call class. This is the class. It sort of defines homehood. The set of all possible homes are defined by this. So this parameter in person is a home. We're going to give, ladies and gentlemen, each person a home in this model. Is that okay? Okay, now, let's continue on this path, okay? Okay, great. So now I would like to do the following. In the project, under, we want to give, okay, so we've just said that each person has a home. That's part of our theory of personhood. People are associated with homes. Where do we go to actually specify the particular homes associated with a person? Or the homes associated with where do we go to sort of assign who gets what home? Where do we go for that?
Maine?
It is in Maine, and where in Maine? Where in Maine? Whence in Maine? Where did we assign, in their very first model, their income? Where did we assign their age, their sex? In the population, indeed. And there, ladies and gentlemen, remember, we can give a formula for how we determine a given person's home. Notice it gives you a little hint here, which it'll tell you, okay, what number of the person in the population am I using? And you could look that up in a database if you want to suck it in from a database. But for now, we're going to draw this, we're going to give them a random home, a randomly chosen home. Are we ready for that? Homes.random. That's what we do. Homes.random. Just like that. Are we okay? Okay. Okay. Annie?
And will this potentially assign what same homes to multiple different people?
It could. And remember, there's 3 people per home on average, so that's okay. So we're going to be sorting people at random into homes.
And you could specify that.
Yes, we could. Yeah, we could have it, and in fact, we'd use this thing right here, Matthew. So Matthew's question is, right now we're going to be potentially assigning multiple people to a home. And in fact, yes, that has to be the case by the Pigeonhole principle. If you have 1,200 people and only 400 homes, that they're going to have to be, only 1/3 as many homes as people. They're going to have to be several people going to at least one home, right? Perhaps it would be a group home. In this case, however, we could, instead of sorting them randomly, we could use an index here to sort of sort them into very systematically. The first 3 people go to home home 0. The second 3 people go to home 1. The third 3 people go to the home 2. We could do something like that using this index. But for right now, we're just going to assign them to a random home. Are we okay with that? Okay, so ladies and gentlemen, what I'd like to do is to actually, we could do this in several ways. I'd love to actually show it visually right now, okay? Right. Okay. So, ladies and gentlemen, I'd like you to go to person, and we're going to do something that we're going to replace later, okay? We're going to expand on later. So we're going to add in here a state chart, okay? And this is going to be called, the state chart we're going to add to person is going to be called care-seeking state chart. Okay, I'm going to drag it in. We're going to actually have 2 state charts. This is going to be called care-seeking state chart. And we're going to add in a first state that's going to be called not under care. Not under care. Just like that. Okay? Who else needs help? I know I've been going pretty quick here. Okay? Okay? Ladies and gentlemen, so we have this not under care. This is what I'd like you to do. For this incoming transition to not under care, ladies and gentlemen, I'd like to do the following. Okay? Are we ready for this? Who needs a little bit more time? So I went to person. I added something called a care-seeking state chart using the state chart entry point, and then I added a state called not under care. And now I'm going to add an action associated with this entry point, okay? An action associated with that entry point. And the action is going to be quite simple, and I think you'll get a sense of what it will do. I will say this, in other words, myself, dot jump to home. What do you think that does? Okay. I was thinking that would work just directly like that, but it's a rather unhappy camper, and I'll have to go back to my traditional way of doing it. Fine. I can't go do that to home. Yeah, it's not a point. Okay, get point. Okay. Okay, we'll just do it this way. Jump to home.getX, home.getY. Fine. Okay, this is what we want. Let me just build that and it'll be happy. Man, I thought, yeah, there's a sweeter way to do it, but I'll be fine. This dot jump to myself, I go to the location of my home, X as in X and Y coordinates. Okay?
Where do you put that?
I put it in the entry here. This little thing here. When they're coming in on this, there's an action. When they enter the state chart, do you see that? So that's whither it goes. Home.getX. What do you think that does? Home.getX. Yeah, it gets the X coordinate for that. And home.getY, that's the Y coordinate, right? Okay, forgive me, I'm gonna be creating a pointer. So home.getX gets the X coordinate, and home.getY gets the Y coordinate, and I jump to it. Now, if I wanted to be picky about these things, ladies and gentlemen, I would I actually should have said this dot home, my home. You don't have to do this, but just to make sure people are on the same page. I think it's getting a little bit wordy to use this everywhere, so I'm starting to leave it out. If by default, if it's not there, it means my home, okay? This dot home. Okay, oops, there we are. Okay, are we ready to go on? We ready to run this model? Let's run it. What do you think you'll see now? What do you?
Assigned to homes?
People are assigned to homes. Where are those people?
No.
Whither have they gone?
They're all home.
Yeah, those are not chimneys, ladies and gentlemen. Those are heads. Okay? Now let me show you a useful fact, if I may. A useful fact that you may wish to use. So if you go up to main, you'll notice that the home is in front of the person. Let's change that order, shall we not? If you right-click on this, you can change the order. This is quite similar to like what you have in Office, right? You could send it to the back. Have you ever done that in Office? Send to back, bring forward. So you could do send to back, and then you'll have the person in front of the home. And the person will be arrayed in front of their home. There they are. Now they stand in front of their home. And there's a few homes by the luck of the draw that are currently vacant. Okay? The people are in front of their home. Why did they suddenly go into their home? Because we jumped them to their home when they came in. Oh, okay, that was weird. We jumped them to their home when they came in here. They jumped to their home's location. Are we okay with that? Okay, ladies and gentlemen. I would like to go now to I would like to go and add a clinic class. A clinic. New agent type clinic. Okay? And we will add to this clinic the same representation we used this morning, to wit, a visual depiction of a storefront. There we are. Okay? Okay, great. Okay. Right. Excellent. So now, ladies and gentlemen, I would like to add a population of clinics to this model.
Are we gonna leave it called a store or?
Well, yeah, we could. That's a good question. We could call it. Clinic image, something like that, or clinic icon. It's a good question. Thank you for spotting that. And I don't think we'll need it, but we'll call it clinic image or clinic icon. Ladies and gentlemen, we want to add a population of clinics. How do we do that?
Main,
Indeed, we go to main
drag it across.
and we drag it over. So we're going to drag here clinics. Now this one I want to put up. Well, we'll put it here first. We'll call it clinics. Clinics. Okay? And this will be a population of agent. And we're going to have a parameter called count clinics. Count clinics. Here. Count clinics. Okay? And this parameter will be of type what? Integer. It will complain bitterly if it's not. Default value will be 1. And for the clinics, make sure it's a population of agents. Mark my words. Make sure the clinics are indicated as a population of agents. And the initial number of agents will be 1. Okay? Okay. There we go. Great. Okay, ladies and gentlemen, let's run the model. Run the model, okay? What do you think you'll see now? What
It's a clinic here.
Yes, there's a clinic now. Now, being after lunch, I want to make things a little bit more interactive yet. Thus far, you've been exercising your skills. First thing I'm going to do, ladies and gentlemen, I'm going to move these down here just below. All three of them in turn. Boom, just like that. I'd like you to see the change. Who needs a little bit more time to do that? I'm in Maine. I'm in Maine, and I drag them down. Are we ready? Ready to try it? Okay, ladies and gentlemen. What happens if we run the model now? What will we see? How will it be different from what we've just been seeing? No?
Not much at all.
Not, mumble. Okay, in earlier versions of AnyLogic, it would actually put their location, their upper left image location. Yes, Dylan?
Yeah, so now there's an option for draw agent with offset to this position in the presentation.
Oh, I see. So it isn't taken relative to its.
Yeah, no, just click on one of those.
Click on one of them.
Yeah, no, stop touching.
Yep, click on one of them.
Position and size.
Yeah.
I think it's no, it's advanced. Sorry. Draw agent with offset to this position.
Okay. So we got to do it for each of them, though.
Yeah. So the reason it's done that, I think,
Yeah.
is because with the introduction of GIS space.
Yeah.
Now there's a few more options going there, so that they
Right.
have to.
But I do want to move it back here because now we don't need it there, right? Or because is it purely? Oh no, it's only okay. It doesn't allow you to specify the offset. Okay, fine. I'll drag them down. Okay. So you're saying in GIS there's some interaction with GIS.
It seems that that feature popped up when GIS appeared, so I imagine there's something under the hood that did that happen.
Okay.
So, should work now.
Okay. No, but we have to do it for each of them separately, I think, right?
Well, you selected all of them, then you click down there, so.
Let's make sure they're all selected here. Yeah. Okay. Yep, they're all clicked. Okay, great. There we go. Great. Okay, great. So now let's do run with that, and now we should see it. Okay, great. So now these things aren't cluttered by the presence of these. Okay? Thank you, Dylan. That's great. Okay. So are you folks seeing that? Okay. Okay, now I'd like to do something different. Yeah. I would like to go to the palette, and I'd like to go to the controls area of the palette. Now this is something new. And you notice here that AnyLogic provides a number of what are sometimes called controls for the user interface. Sometimes they're called widgets. And one of them is called button. And that's the one on which we'll focus our attention right now. This button, we're going to drag it over so it lies up here. Okay? And we're going to use it to have a glimpse of something that's coming up. Indeed, I am weaving together several lines of learning in this example to spare us time and to open tomorrow for a thoroughgoing examination of GIS models. Okay? So, I just dragged this button over, and this button will be called Add Clinics button. And the label on it will be Add Clinic. And when we add the clinic, when we press that button, this action will fire. When we press the up button, it will do whatever we tell it in the action. Remember we saw that before with events? We could add this event thing. Do you remember that? We could have this event going off periodically, and each time it fired, it would do something. Like every year it would go off, and we'd record how many people got infected in the past year, or how many people got diabetes in the past year, save it away to a data set, and reset that. Remember that? It's the same idea here, except here, the action will be fired when we press the button interactively. Just like that. Are we ready for that? Okay, great. Okay, ladies and gentlemen. The action here will be this, meaning reference to main, dot clinics, add underbar clinics. We're going to add a clinic. Add to the clinic population. Now that's going to provide a glimpse of how we achieve open populations. We're going to be able to have immigration going on. And do you think it will, if we had immigration in this model, what do you think it would be? Would it be add underbar clinics? It would be add underbar what? Population. If births occurred in the model, if a person in the model were to give birth to have a new baby born, they would call add underbar population and actually give information on the baby's characteristics. For example, what sex it was, what his birth weight was, etc.
So add is a function within any logic, is it?
Yeah, so when you add a population, any logic automatically provides certain features for that population, and one of them is the ability to add things to it by calling add underbar population in main. Another thing you could do is remove people from that population, so remove underbar population from main. Okay?
And you follow again with the empty brackets at the end.
Yeah, the empty brackets is just like it's because we're calling something, like calling sign, but unlike the sign function, it doesn't need any information to do its job. So it's a call where it doesn't need to be told anything. Now, if we had clinics, if clinics had parameters, then we'd want to specify the parameter values there, okay? Or if like we were adding a person, and a person had let's say people have a birth time, a sex, and an ethnicity, we'd need to specify that when we add them. So if we add underbar population, we'd specify the birth time, sex, and ethnicity of the new baby, or of the immigrant coming in. And we'll probably be doing that in time enough, but in the closing time of this afternoon. But we have some work to do first. Okay? Ladies and gentlemen, so add clinics. Are we okay with that? Okay, ladies and gentlemen, I'd like you to go to the projects, and I'd like you to run this button. Run this model. And here we run it, and here's an add clinic. Do you see that? Yeah? There's a button. What should we do with it? Press it. What happens when we press it? Okay, one clinic appeared, but now we have 8 clinics, 9 clinics. Where are they going? Well, turns out that they're all going to that place, okay? So we want actually them to be distributed around evenly. So let's do this with clinics. So that was an interesting fact, Dylan. So I would have expected them to be at the home location, not yeah. And why they appeared there, I'm not quite sure. But for clinics, let's go to clinics, and we're going to say initial location, place agent at the specified point, and we're going to actually give a formula for the specified point. Uniform between 0 and this dot space width. Remember that from our very earliest forays? Do you remember that? I used it to teach a lesson about what these things were doing. This dot space height. Let me put that up on the big screen, which it graced just yesterday. Okay, here we are. That's what I want. So it finds out the space width, and then it draws a value for x between 0 and that space width. Finds out the space height, and draws a value for y between 0 and that space height. That's what we want. Wherein lies that? Wherein lies it? It's within clinics in X and Y for their initial location. How did I see that? I pressed in the specified point here. Are we okay with that? Now, if you have, mark my words, if you have a dynamic population, a population that's coming in over time, this is how you do layout of the new person. Do you remember when I went to Maine earlier and we went down to the layout area and you said random layout? That works okay for the initial population. It doesn't work well when you have a population coming in. If you want a population coming in, whether it's through pressing a button or through immigration or birth, you'll need to do it with this initial location thing. Okay. But it's good to know about the other way for the initial population. Makes it very easy. Okay, are we ready? Who would like a little bit more time to put that in? Okay, we're cooking with gas, ladies and gentlemen. Let us run them all. Okay, here we go. And let's go add them. And here are our clinics. Wheretofore art thou appearing? They're appearing all over the place, okay? They're appearing as we add the clinics, they're distributed through the space. Do you see that? Okay. Ladies and gentlemen, so we've got basic infrastructure in place. Now, I would like to start putting in place the mechanisms for the dynamics. Okay. Now, we're going to do so with a bit of forethought because we have to make pretty good progress here. And there's some things that normally I do in the course of things coming back to and doing things, but I want to lay the groundwork in place. And we're almost done with it. And then we'll start really getting down to the core logic. Ladies and gentlemen, I would like you to do new, create an option list. And this option list, too, will be something we have not, type of option list, function of it we haven't seen before. The option list name will be nothing less, ladies and gentlemen, than messages with a capital M. Messages. This will be a set of messages that agents will send to others and to themselves to get them to undertake certain tasks. Okay? Okay. Okay. Okay, so ladies and gentlemen, great. Very interesting. Okay, ladies and gentlemen, so within this messages, I would like to put in 3 messages. And we're going to be using these in coming minutes. To wit, cured, with a capital C, exposed to a pathogen, and finally, departed healthcare facility. Okay? Cured, exposed, and departed healthcare facility. Now, I've taken the liberty of spelling healthcare as one word rather than as two, so the capital, it's lowercase c, but if you feel strongly about it the other way, you can choose otherwise. Okay. Okay? So what did I do? I went to add an option list, new option list, and I did messages, and then oh gosh, I didn't want to do that. And then I gave those 3 values for that in messages. Cured, exposed, departed healthcare facility. I did it by clicking in there. How many people would like a little bit more time to catch up? Okay? Okay. Here are my messages here. And I would be glad to show anything. Would you like me to show something for what I've done? Would you like me to show something?
Does anybody need any help directly?
People like some help?
Oh, the math's a bit funny, but
for the option list?
Yeah.
Where-
What's happened with the option list?
It's just, you find things on the map.
Okay, do you have to press plus instead of directly clicking on it?
Yeah.
If you press plus, it deletes the one you tried.
If you do it and then press enter and then press.
Then you press like.
Oh, you press enter and then press plus? So you enter one, so you type one, and then you press enter and then do plus, and then it will let you get ready for the next one. Okay. My apologies about that. Jeff, could you take that down? Thanks. We'll report that back to colleagues at AnyLogic. Okay. Okay, are we, do you want a little bit more time? People want some more time? No? Okay. Okay, so ladies and gentlemen, I'd like you to now go one step further with this. Specifically, I would like you to go and, yes, okay, so I would like you to go to main, and we're going to do something we haven't yet done, another thing we haven't yet done before. Okay, in main, I would like you to go to the properties of main, and once again go down to this area called space and network. Do you see that? Space and network. And now I'd like you to go to the area where it says network type. Okay? Do you see that? And I would like you to choose distance-based network. Okay? And I would like you to choose a connection range here, which I'm going to specify for you for this case, but in general you might tune it for certain properties. And it's going to be a distance threshold of 75. Okay? Okay. 75 units. Now, the units of distance in AnyLogic can be specified in several ways. You'll notice if you go up in main, there's this legend here, which allows you to specify how big is the physical distance associated with the kind of visual distance in the model. Each pixel here is a very small unit of display, but 10 of them constitute one of these sort of lines of one of these boxes. And each of them corresponds to 1 meter, let's say. Okay? So we might want to say instead that each of those corresponds to, for example, 1,000 meters. That's 1 kilometer. Or we could simply say 1 kilometer. Okay? Now, the only problem is if we do that, certain things become not so visible. Did you notice that house became very large for a moment? Watch this. If I say this is 1 meter, the house looms large. Indeed, the very person is large. If I said 10 meters, that house becomes smaller. If I said 100 meters, it's barely visible. So what I'm going to say, ladies and gentlemen, is I'm going to return this to its default value, okay? Where we had essentially 10 pixels per meter, okay? Ruler length here corresponds to 10 meters. We could go and we could change it. It's just visually it's going to be a bit hard to see, so I'm going to leave it as default. Just be aware that you can change the physical distance associated with the virtual distance, and that's going to make our speeds a little bit wonky here. But I want to make sure that things are visible. Okay, so ladies and gentlemen, I would like to now go back to the model. Oh, and go to person, double click on person. We just set it so that, and I'd like to describe what that means. I'm sorry, you don't have to go with me, but I just want to go back to main to show this thing. When we set a distance-based network of length 75, what this means is that two people, ladies and gentlemen, who lie within 75 of those units of each other, those visual units, if a given pair of people lie within 75 units, they'll be connected in a network. Otherwise not. So we're going to have what's called a distance-based network, a network associated with locality. A given pair of people will be connected if they're close enough. In other words, it captures the property of propinquity. The fact that two people are much more likely to be connected if they are close together in space. Okay? So, ladies and gentlemen, if we ran this model, they would be connected. We just wouldn't see it yet. I'd like to change it so we can see it. And to do that, I'd like you to go to person. Okay? Double click on person and open it. Now, I would like you to make sure that this area that says connections here is visible. That area can be seen readily, because it is upon that area that we will be operating. It's called connections. And we are going to, in the connections area, go down to animation, and we will draw a line between agents. Do you see that? So it's down in the animation area. You may have to expand it. It's draw a line connecting agents. Do you see that? And I would like to, we can leave the defaults there. So we've drawn a line connecting agents. The network was there logically without this. This will just help us see the network. And with your leave, I will now run the model. And I suggest that you do the same. Okay, so I'd like you to run it. Okay. Oh my gosh. The model would the indication is that the model's network is dense. Okay, let's go tune some parameters. I'm not quite sure why my notes are off in that regard, but let's go adjust some parameters. How can we make the network less dense? Can anyone read that, reason that through that to me? What could I change that might make each person be connected with fewer individuals?
Reduce the connection.
Yeah, reduce the connection range. So where did we find the connection range? It was in main. It's in main. And scroll down to the network area. You'll see there's a whole bunch of different types of networks that we can use. And as time allows, we'll explore them. But for right now, I'd like to change the connection range, ladies and gentlemen, to something much smaller. Let's try another extreme, which I believe may be equally adverse. 10. 10 units, ladies and gentlemen. A given pair of people will be connected if and only if they lie within 10 units. But I actually think that this is not fully the reason for the issue. I think this is slightly an AnyLogic issue. I believe that our AnyLogic version issue. I believe actually people are being connected with homes, and people are being connected with clinics that lie in their range too. So we're going to need to do a bit of fix-up. This is something that changed a little bit between versions. Ladies and gentlemen, up in this area here, I would like you, well, first of all, let's go run it. Let's go see the effects of that connection range here. Let's go run it here, and you will see, okay, now there's less dense connections. But people, it turns out, are still connected with many other things, including with clinics. So I'd like you to actually go here and okay, I'm just thinking here. Dealing with some risk management. Okay, fine. We're going to go to main, and we will go in main, and we will uncheck the boxes next to homes and clinics here for placement in networks. Okay. Now this is going to have an implication for us that we're going to have to fix up slightly. I can see Dylan is wondering where I'm going with this. So we're going to uncheck this, and we are going to now run the model and see the consequences, and then we'll fix it up. Okay, ready? So I'd like you to run it, and we will now see people all in one location. Why is that? Well, we have to tell the homes where to lay themselves out. So I apologize, folks, but we need to tell homes, just as we did clinics, we have to use this exact same information. So we're going to copy from this X location for clinics to the corresponding X location for homes. So we're going to go to the homes collection, select in the specified point, and we're going to copy over what we did for X for clinics and copy it over for homes. I apologize, but things did seem to change between versions of AnyLogic, and I need to fix that up. Similarly for Y, we're going to change it here, and there we go. Are we okay with that? Okay. And now I'd like to run it. Okay. Okay. Now we have it fixed up. That's not the only way we could have fixed it. We could have had the network connections only be connected with other people. And that would have also worked. Yeah, I know, I feel the same. I agree with Dylan. Okay, so ladies and gentlemen, are we okay with this? What would you like me to show? What would you like me to show you from what I've done? I've done a couple things quickly there. So let me rehearse what I did again. Ready? I went to main, I scrolled down, and I set this so that we would have a distance-based connection range of 10. I unchecked these boxes next to clinics and homes. And then, ladies and gentlemen, I went to homes. I made this, the initial location be in the specified point, and I copied the formulas from clinics for X and Y to the corresponding boxes for homes. That's what I've done. And then I ran it, and it seems to be a fairly happy camper. Okay, so I'm going to run this thing here again, and here we have some linkages between these things. Okay. Okay. So, ladies and gentlemen, so this is good. So we have linkages between two people if they lie within a certain distance of each other. Great. Okay, ladies and gentlemen, I would like now to proceed with the next little bit, which will be some heavier lifting. Okay? So, with this set up, I would like to add 3 parameters to main. These parameters will relate to the natural history of infection. Actually, yes, three of them will relate to natural history of infection and people's patterns. These parameters will be drawn from the palette, as we are wont. The parameters will be named successively. Parameter 1, all of them are double precision values. One will be incubation period in days. The next will be contacts per day. Contacts per day. And the next will be will be infectivity or infective duration in days. Now, each of them is going to have a value that I will read out. Let me read out their names though. Incubation period in days, contacts per day, infective duration in days. I am putting these in main because I want to be able to vary them by experiment. Incubation period in days, contacts per day, infective period in days.
So just on that, if you put them in clinic or person, you wouldn't be able to vary them by experiment.
Right, because the experiment knows about the parameters in main.
Oh,
And those are the parameters that it specifies. Remember, parameters serve two functions. One is to encode an assumption. The other is to communicate that assumption from the point of creation to the thing holding the parameter. So main, it's created by the experiment. So any parameters it has are communicated by the experiment to it. If a parameter is in person, it will be communicated by the population, for example, but main won't get involved. Okay? So if you want to change something on a per experiment basis, you want a parameter in main corresponding to that. Now, maybe you also have a parameter in person, and maybe main just passes that parameter on to person, but you definitely want a parameter in main. Okay? Okay. Okay, so values here, ladies and gentlemen. Incubation period in days should be 3 days. 3 days. 3 days before we become infective, following infection. Contacts per day, 1. Infective period duration, 10 days. Longer infection, I mean, pertussis can be quite a bit longer yet, but, not 1 0, 1 0, 1 0.
And
10.
even though you're putting those in as integers, they're actually double.
Correct, and it probably, just to make that clear, just to be consistent with my injunction, contacts per day 1.0, and incubation period in days 3.0. Never hurts to do that, and it can help prevent problems, particularly with division. If you put 1 divided by 3, it'd be 0. If it's 1.0 divided by 3.0, it'd be 1/3, it'd be 0.3333. Great. Okay, the final thing I want to put is going to be a parameter called fraction initially infective. And its default value would be 0.01. Okay. Apologies for the trouble, but we need to put that into place. And now we'll go make use of those parameters. To wit, in person. And for initializing person. Okay, who would like help with this? Who would like me to show something? We've been going on for a bit with this model, and I'd be happy to show something. I know I've been asking a lot of you. Okay, are we ready to go? Okay, ready? Okay, let's now continue on then. Okay, ladies and gentlemen, I would like us, we're going to sort of break the monotony here. We're going to do something a little bit out of order, okay? And it will enliven things, I hope. Okay, so let's go down to person. Notice if you have multiple projects at the same time open, you have to be quite careful about which one you open. We're going to put it down here for care-seeking state chart. We're going to add a few components. To wit, ladies and gentlemen, I would like to add a state called in transit to care. In transit to care. In transit to care. And I would like to have a state called under care. Under care. Under care. And ladies and gentlemen, I would like to connect these up. Connect these up, okay? So, great. So I would like you to put a transition between not under care and in transit to care. Put a transition between in transit to care and under care. And put a transition from under care to not under care. Okay, just like that. Do you see that? Just like that. Not under care, in transit to care, under care, and some transitions here. And we're going to deal with the nature of those transitions in a minute. But one of them, in particular, I'd like to specify right now. Okay. Ladies and gentlemen, for in transit to care, I would like to make this a new type of transition. Not a timeout, ladies and gentlemen. Not a RAID, nor a condition or message, the latter one of which we will soon explore, but an agent arrival transition. When the agent arrives at its destination, they will now be done with the transit and will be under care. So that's step one. Okay, ladies and gentlemen, next, I'd like you to add in a variable. And this variable will be called nearest clinic. And what sort of variable do you think, what sort of type will that variable hold? Anyone want to hazard a guess?
Clinic.
It'll be a clinic, indeed. It's a clinic. It's a reference to a clinic. It's that one, or that one, or that one. And we'll be able to ask about its properties, etc. So I've added nearest clinic. And it's of type clinic. So what did I do? Let's rehearse it now. I had this rump state chart. I added in 2 additional states, in transit to care, under care. I added in 3 transitions. I left 2 of them alone, and I made this one an agent arrival transition. I then created a variable called nearest clinic, which is of type clinic. And this, ladies and gentlemen, will be associated with care seeking. And this, ladies and gentlemen, will lay the groundwork for achieving a hybrid model. Okay, so, ladies and gentlemen, but right now, our task is a little bit simpler. So, ladies and gentlemen, for this transition here, from not seeking care to in transit to care, I'd like you to do the following. I'd like you to set it to be, the action should be nearest clinic equals this dot get nearest agent from which agents? We have to tell get nearest agent which set of agents to consider. And the agents will be all clinics. Where do the clinics live? Where do the clinics live? Where's the collection of clinics, the population of clinics? It's in Maine. Maine dot clinics. There we go. This is what I want, ladies and gentlemen. That is what I want. Nearest clinic, in other words, the nearest clinic. And if I want to be very sort of verbose about it, I could say this dot my nearest clinic is get the nearest agent to me of all those that live in Maine clinics. Find the closest clinic to me. And this will mean as we add new clinics, they'll take into account. Think about a model we'll be doing tomorrow where we have parks. If you want to add new parks in dynamically, how would that change things? If you want to add supermarkets in with good fresh fruits and vegetables, how would that change things? This will allow the agent to incorporate, it'll go to the nearest one, and it will find it each time. Okay, ladies and gentlemen, so I said nearest clinic equals that, and now the next line here, I'll put this on the big screen, will be this dot move to, move myself to nearest clinic dot get X and nearest clinic dot get Y. Dylan, can you look into the AnyLogic API and I mean, there's got to be a better way than just specifying the X and Y. You must be able to say like this dot moved. I wish you could say this dot moved to nearest clinic, but you can't. Can you say this dot moved to nearest clinic dot get point or something like?
Right now, one of the easiest things off the top of my head is dot get X, Y, Z, because I'm using 3D point and then it's.
Yeah. Okay. Yeah. Yeah. Okay. Okay. That's less verbose.
But, I'll see if I can find something better. I know I've encountered the same issue as well. It feels very weird that you can't just say to the agent, because I mean, it should be obvious.
It should be obvious. Right.
It might conflict with something. Anyway, I'll take a look.
Okay, so this is what I have here, and let me make sure it builds okay. So first what I do is, just a sec, First what I do is I find out the nearest clinic to me, and then I move to it. I move to its location. Okay? Great. And then, ladies and gentlemen, we're almost done with the essentials of this, or with some of the essentials of the state chart as far as mobility is concerned. Do you want this up a little bit longer? Who would like it up a little bit longer? Are you ready to go to the next one? Okay, then ladies and gentlemen, Dylan, Annie? Okay, so ladies and gentlemen, for this transition here, going back to non-under care, I would like to do a similar thing, but instead of being moved to nearest clinic, this is what it will be. In fact, we can even copy it. It's up here, okay? Oh, no, we can't copy it. It's not quite the same, sorry. Instead of saying that, what we'll be saying instead is the following. It'll be this move to home.getX. Home.getY. That's what we'll have. That's what's associated with this point. That's what it is. Okay, there we go. This dot move to home.getX, comma. So this is going to, for a given person, they have a home. It's going to get its X value, get its Y value. I could have made it this dot home dot my home, but that's implicit, so I'm leaving it out now. This dot get X. This is the X of their home. This is the Y coordinate of their home, and I'm passing it to move to. Okay? Are we ready? Do you want a little bit more time? A little bit more?
That's for the transition under care to non-under care, is it?
That's from under care to non-under care. Okay, so let's run it. What do you think we'll see now? What's going on? Everyone goes to that clinic. They're a bit fast about their transit, though. So, ladies and gentlemen, let's stop it. Let's slow them down. And as I said, we're being a bit generous a bit loose with the distance. So, I'm going to set their initial speed to not 10 meters a second, which is aggressive in its speed. Instead, we're going to set it to a more modest rate indeed. The initial speed, So I went to person, I just went to person, and I went down to the movement area of person, and I'm going to set their initial speed to be 0.01 meters per second. Okay? Not 10, not 1, but 0.01. Okay, Dylan, you want me to show something?
Well, I was actually just going through the API there, and in 7.2, they actually do have move to agent.
Oh.
So like move to, and then it
You could just say move to home.
Yeah, and so I'm not sure if, like maybe 7.1.2 that you have does, but.
No, it didn't. It was
Okay,
unhappy.
It seems like such a strange thing for them to introduce so late, but it is there for the vast majority of participants. They can use it.
Okay, there we go. Is this what you see now? Okay, okay, let's slow this down so we could see it in more detail, what's going on. Okay, welcome to the Bat Cave. So these agents are circulating. They're not all in sync. Those, because they get thrown out of sync because they head back, not at the same time of day, but exactly one time after they get there. So those from a similar distance are sort of coming in together at the same time. It's a little bit distracting with the network. So with your leave, I'm going to turn off the network. Okay? So I'd like you to go to person, and let's just turn off the visibility of the network. We're going to go back, and we're going to go to connections here, and I'd like you, in the connections for person, I'd like to uncheck draw line connecting agents. Okay? I'd like to uncheck that, draw line connecting agents. And now I'd like to run it again. Okay? Here we go. So you could see more clearly what's going on there.
So looking at that, does that mean that they don't have enough time, the ones that live far away from the clinic, to actually get home before they go back again?
Yeah.
That would be, no, they actually get there. They get there and they stay there for 1 hour. Why do I say 1 hour? Because this is a timeout of 1 hour after they get there, then they go back. So they actually are getting there and going back. It's just that they get out of sync with the others because the others get there first, and an hour after they get there, they go back. So we're getting this kind of pulsating effect associated with that. But they go back to their home, and just after an hour at home, they return, which is quite quite an involved pattern. Okay, so ladies and gentlemen, we're going to now go and add some logic that will be associated with their health state. Okay, and this is going to teach a separate set of lessons, a set of lessons involving aspects of spread of disease. Yeah.
Just quickly, that parameter home there, what does that do?
So that is their home. That's encoding their home location. Mm-hmm. And you may remember, this is a home. You may remember that back in Maine, do you remember when we had in Maine?
Yeah.
We went to the population, we assigned each person a random home. So in the population in Maine, we assigned each person a random home. And ladies and gentlemen, when we assign them a random home, they then use that home. They then use that home to, remember here, in coming in here, they went to their home, and then here they're going home. They're going home from the clinic.
Yep.
So that's sort of where where they're associated. Now, ladies and gentlemen, we're going to have their clinic-seeking behavior be driven instead by their health status. Okay? And that lies for us after the break. So I think there's food there. We'll make use of it, and we'll return in 10 minutes to have to finish this with a state chart where they have health status evolving, and that health status will drive them into care or not. Okay? Yes? There is. I'll show you how. So you see this description thing? You can, in fact, it's very good practice to provide metadata, like for the source of parameters there, or to give the source of why, like what the explanation is for why you're doing this. You can put it in this description field. And I will tell you, there's been 1 or 2 times in my life as a modeler where having that data there visible for a stakeholder has made the difference. In one case, it was like a $2 million difference in the contract. Because they saw this, they actually wanted to drill down, and wherever they went, they saw comments. And that meant that, okay, they had confidence that this model was well put together, was well documented, was grounded in real sort of care, and because of that, they were much more comfortable with it. So having this metadata filled in, like in the description area, is very good practice. Okay? Yeah.